How's that? Can you see my screen there?
Yes.
Great. Okay. Thank you very much, and thank you for the invitation to speak here. As Adam said, I'll speak mostly about the carbon cost of food, and I'll talk both about production and consumption of foods. So I'm John Hillier, as you see. I'm based at the University of Edinburgh in the Global Academy of Agriculture and Food Systems. I actually live in Dundee. So I'm glad, having heard Rachel's advice and David's advice just now, that I took the decision to present remotely rather than drive up to Aberdeen this evening, which I was contemplating when Adam and I spoke earlier. I think, I'll go through some slides that will probably be quite familiar to most people here, but nevertheless, I think it's worth going through. You've heard David talk about the 1.5 degrees, which is universally agreed to be the target that we need to achieve, so to limit global warming to 1.5 degrees to avoid the most serious impacts of climate change. And from this graph, you can see four different emissions pathways, as they're called by the IPCC. And you can see that basically for all of the blue and the green one, which are the ones which limit global warming to 1.5 or 2 degrees, they basically, both of those require immediate action. You can see that the action starts at 2020, and quite dramatic cuts in global emissions from now. If we wait until 2030, that's the dark blue purplish line on the graph, then we will overshoot that 2-degree target, and we will have to work harder then to get down to 1.5 afterwards. And in fact, currently, we're still going in the wrong direction. So this is the red line there that you see is the trend from the recent IPCC 6th assessment report. This is the trend that our global emissions will take based on recent implemented policies and national commitments. So there is still there is a huge challenge ahead of us. I've been working in this area probably for about 15 years now, maybe slightly more. And although, we're still going in the wrong direction, I do see more grounds for optimism than I did when I started. And these two, you can see I'm a Guardian reader from this, but these two articles from The Guardian, 11 years apart, are actually quite interesting in terms of observing the sea change in public opinion. So when I first used to present on this, but back in the day, you'd have to preface almost every presentation by something to do with whether climate change was real or not, what the evidence was. Because at that time, the majority of the British public and the public generally believed that climate scientists were exaggerating. If they believed it at all, they believed that climate scientists were exaggerating the danger of climate change. And if you contrast that to this article on the right there, which was 2019, which concluded that 2/3 of Britons now agree that the planet is in a climate emergency. And I think, to be honest, it gives me no pleasure to have been proved right. It was a serious issue. It's still a serious issue. It's depressing in many ways that there hasn't been action since the evidence was so clear a long time ago. But nevertheless, I think there's more of a groundswell of opinion and more of a basis for change than we had back in the day. As I said, I'll talk mostly about food, and from here on, it will be mostly about agriculture. And in fact, these two slides, when I was putting this one together, I was actually thinking about whether I should show a graph which had atmospheric carbon dioxide emissions as well on the same timeline, and I decided not to. I was in fact very pleased that David did that. And you can see that you're basically looking at mirrors of the same graph. The big elephant in the room with things like climate change is that it's really directly linked to global population. So since our population has dramatically increased in the last 150 or so years, so have our global emissions, and so has our land use. So the graphs on the right show that the percentage of global land area that's under agricultural production. So rising to around about 50% now if you include land which is cropland and grassland. And of course, that's not, to me, that's not really all that surprising when you think about it. If we've got this growing population, then the challenge is to feed that growing population. And we haven't yet dissociated food production from land use or ocean use, which I'll talk about slightly later. Nevertheless, we still, this sort of figure that I'll repeat here, that around about a quarter of our global emissions come from agriculture or land use change, which is often associated with agriculture. This is a big figure that's often quoted, and sometimes I think that food production kind of gets the raw end of that, when you think it's probably, at least to my mind, it's probably the most essential service provided for humanity. If we don't have food, many other things that we kind of think as normal and required in our daily life are irrelevant. So to provide that absolutely essential service and still be responsible only for 1/4 of global emissions, I think that agriculture receives, or our food system receives, an undue degree of criticism. That said, a quarter is still a big number, and we need to act on it. And what I will show you after this is, I think, ways that we as consumers can take action, and ways that farmers and producers can also take action, and the food system. This, I guess, this kind of effect you see on this graph will also be familiar to many people here. So what I've plotted there are the carbon footprints of different food types. So it's carbon equivalent emissions per kilogram of edible products. And the effect there is fairly obvious. We've maybe seen these before, that you have plant-based foods. On my graph, these are the green ones down at the bottom. And at the top of the graph, you have ruminant livestock systems, which really get demonized. And you can see why they're a target when you look at this graph. The emissions from ruminant livestock systems, those top 5 categories, are many times more than plant-based foods. Most of us probably know that non-ruminants, so things like pigs and chickens, are somewhere in the middle. These are the other 2 yellow bars in the middle, and the other blue ones there. When I've looked at these graphs in the past, you often see one thing or 2 things which say something like fish or seafood, and it's stuck somewhere on that graph, somewhere between plants and ruminants. But there's a recent publication now from 2021 that actually differentiates between a whole load of different types of seafood, so right from things like bivalves and mollusks, which are very low emissions and can be farmed for not very much. And then there are some which require really deep trawling, and the emissions from those, from capture of those seafoods, are much higher. Nevertheless, this is the graph. It's probably familiar to most people, and it divides up pretty much as I've got it on the left set there. So ruminants up at the top, plants down at the bottom, and everything else in between somewhere. These are the main sort of big raw produce globally. Of course, there are lots of other products, and there's variation around that, but these are the big kind of traded commodities, I think. From that graph, of course, it's quite natural then to think about, as consumers, the natural conclusion for us is to say, well, if we want to reduce our carbon footprint, then we should eat fewer of those ruminant products, and we should have more and more plant-based foods. And this publication back in 2016, so I've borrowed this slide from Professor Pete Smith, Adam's colleague at the University of Aberdeen. You can basically see an assessment there for a whole load of different diets, and it goes right from our current diet down at the bottom there, and then what would happen if you swapped out various products. So if you replaced meat partially, if you adopted, say, a Mediterranean diet, if you had more fish or seafood replacing those meats, right the way to up at the top, if you really cut out animal products completely. And you can see that there's really, there's a lot that can be done, and I think that's absolutely genuine. But to look at the axis on the bottom, and you can probably halve or thereabouts your carbon footprint of your food by cutting out ruminant livestock and going to a vegan diet. In fact, when I was looking for a slide on that, I struggled to find one at first until I contacted Pete. And one of the things I did was just Google low carbon diet and look at the images. And you can see that, that many people have come to the same conclusion. What you see when you look at those images is that it's very much plant dominated. And I think, speaking for myself, that's the challenge. I think so eating more green stuff is a bit like a New Year's resolution for me. I look at these and I think, yeah, I must do more of this. Occasionally I do that. I eat less meat because I know it's good for the planet. I know it's good for me, but I don't always do that. And sometimes I revert back. I think it's some of the struggles that Adam had mentioned before. So I know about this stuff. I struggle to do it. Many people know less about this stuff, so it's not surprising that they struggled. If they have less information. The media, I know other people do a lot better, but I think there is the challenge. There's not a lot of meat on those plates. Many of us find these diets difficult to persist with in the long term, and there's not much meat on them. The one thing I did just want to mention as well, I had seafood a couple of slides back, that many of these healthier diets also advocate swapping out meat products for healthier, oilier fish or other seafood products. There are implications to that. So there is another graph here which looks at areas under fisheries since the 1960s and areas under aquaculture. So that's farmed fish since the 1960s. And you can see a very, very dramatic increase in aquaculture in the last few decades. So if you go from the early 90s up until now, it's multiplied many times. And I think there is a sort of knock-on effect of us swapping out meat products for seafood-based products, is that it will require further growth in our aquaculture industries. And there's a limited amount of fish feed that can be given to those fish farms. So that will probably mean there's more need for plant-based feeds for aquaculture, and that will impact on our land use as well. So it's one of these things where every lever has some consequence. Nothing is free, I think, in terms of the choices we make as a society. There's always a trade-off somewhere and something to consider. And that's the sort of diet side. The stuff that I've been working on for these last 15 years or so is actually on the supply side. And that sixth assessment report I mentioned earlier actually makes that very clear. It says at one point, agriculture, forestry, and land use mitigation options. So that's reduction of greenhouse gas emissions from the use of the land, when sustainably implemented, can deliver large-scale greenhouse gas emissions and emission reductions and enhanced removals. And what's more, there are many co-benefits to many of these things. So, for example, biodiversity conservation and others, avoided risks of climate consequences in the future. So, greater resilience of our production systems. So, there's a strong argument for doing this supply side mitigation. And I'll go into a little bit of the details about this, at least as I see it. And sorry for the technical stuff, but this is sort of quite fundamental, I think. In fact, underpinning our livestock systems and our crop production systems are crops which really depend on nitrogen for production. So some of you may have seen this before. This is a very famous experiment which was held at Rothamsted Research, and it looks at the effects of applying a certain amount of nitrogen to a winter wheat crop consistently year on year, and looking at what that does to the yield of that crop. And what you see is that it's an absolutely, well, in conventional agriculture, yield is very, very strongly tied to nitrogen application rate. So I said conventional agriculture, I mean generally. Yield is in cereal crops is dependent on nitrogen availability and supply. If you don't supply enough nitrogen to things like winter wheat, you get very low yields, around about 2, 3, 4 tons per hectare. And to get the kind of yields that we expect to have in conventional agriculture now, we're actually having to apply or make available around about 150 to 200 kilograms a hectare. And for that, we generally depend on the synthesis of ammonia. So these are big industrial chemistry processes, the synthesis of ammonia, and that's through natural gas, taking the nitrogen out of the air. And also building from that, the synthesis of nitric acid from ammonia. And these two processes are very famous. If you do sort of higher chemistry in Scotland or A-level chemistry in England, you'll learn about the Haber-Bosch process to synthesize ammonia and the Ostwald process to synthesize nitric acid. And there's a really nice book, I'm not promoting anything. This was a great read. It was given to me as a gift once when I presented at a meeting on fertilizers, and it's called The Alchemy of Air. So the challenge is actually nitrogen's all around us, getting it out of the air and getting it into a form that can be used by plants. Took an enormous amount of effort. And in fact, the book starts by saying, well, at the dawn of the 20th century, there was a kind of big sustainability problem as they saw it at the time, was that the European yields for crops were decreasing, and they were dependent on the import of Chilean nitrate. So basically, mining nitrate that could be applied to our crops. And they said, look, we need a more sustainable solution, a more sustainable supply of nitrogen. And this Haber-Bosch process was the answer at the time. And it's become clear to us since that although it did solve the immediate problem of yields, well, over a number of decades, that the consequences of that have been quite significant. I'm going to try and speed up because I feel like I may be taking too long here. In agriculture, David talked about carbon dioxide being the most important greenhouse gas. In agriculture and food production, we often talk about three: carbon dioxide, methane, which is produced in smaller amounts but is around about 25 times more potent over a 100-year time horizon, and also nitrous oxide, which is around 300 times more potent. In other words, you don't need much of that to have a big effect. And this nitrous oxide is part of the consequence of our use of nitrogen in agriculture. There are emissions of nitrous oxide that are important. If I take what I'm going to do three examples now. I'm going to do one which is a conventional cereal crop, and then I'm going to look at non-ruminant livestock, and then I'm going to look at ruminant livestock and just see how the emissions break down for those, typically for those food products, and what we can do about it. Okay, so this is for conventional wheat-to-wheat. This is using my own data and a calculator developed by AHDB called the Carbon Footprint Decision Tool. And you can basically see that up to the farm gate for a typical wheat crop produced in the UK, this is the breakdown of emissions. So the green stuff on that graph are actually the emissions that are due to the production and the use of nitrogen fertiliser. And the rest is energy use, either energy use in synthesizing the agrochemicals that are used on these crops, or the energy use directly on the farm. So in fact, we call it a carbon footprint, but for things like cereal crops that have a high nitrogen demand, we could almost call it the nitrogen footprint. It's 2/3 or more nitrogen, or at least it was back 10 years ago. And I think that highlights one of the things that that industry can do, and that the supply side can do. So, a chunk of that, and this is the light colored, I don't know if you see my cursor, the sort of light colored bar on this graph here. That was nitrous oxide from that Oswald process I mentioned, so for the production of nitrate fertilizers. And in the last 10 years, pretty much every European manufacturer has installed an abatement technology to cut that out. So that part, on the supply side, that part of the emissions profile is now gone. And there are people in the fertilizer industry, companies there, who are seriously now looking at whether they can do that ammonia synthesis without using natural gas. And if they could do it with something like hydrogen, it's a long way from actually being ready, but you wouldn't get that carbon dioxide from the ammonia. And there would be a big saving. So that's probably about another fifth from the emissions signature of a typical wheat crop. The sort of organic solution is to say, well, we don't apply that synthetic fertilizer at all. There are other sources of nitrogen, like legumes or cover crops. And that, of course, is an option. The challenge has always been how to maintain yields, but there are many examples where people do with a lot of effort. I did want to mention with this cutting out the CO2 from fertilizer production is that I always thought this was a great idea. And then I learned last autumn that the food supply chain is absolutely dependent on that CO2. It's used in slaughterhouses, it's used in packaging to preserve the shelf life of meats. And we actually had a situation when the gas prices started to go up last autumn, where the government had to strike a deal with the fertilizer manufacturers who said it's just not worth producing at the moment. It costs us money. It had to be supported so that we had the CO2. So for many years, we're trying to cut that out. And then we found that actually the fertilizer companies were being encouraged to continue production so that we could have the CO2, which is, still quite shocking to me when you think about it. and shows that nothing is simple. Whizzing through, energy is getting greener, that's clear, you know all about that. So we can continue to chip away at anything to do with energy use. The big one that's a real struggle are these nitrous oxide emissions in the field. And that's just something that happens because nitrogen is available, it flows through the soil, and it's very difficult to eliminate it. Although there are some chemical inhibitors that can actually reduce it. So there's lots that can be done to reduce the carbon footprint from a cereal crop. Now, I'm guessing you could probably bring that down to about half with technologies and smart agronomic practices, good efficiency, that sort of thing. Moving on to non-ruminant livestock, some of that plays through because these two systems I've got here, chicken and pigs, they are dependent on feed, and lots of that comes from cereal crops. Okay, so if you could trim the emissions from nitrogen fertiliser, the emissions from energy use from your feed, then you can make a big difference as well to those livestock production systems. So these are the kind of shaded out parts at the top of the graph. If you look at what's left then, typically for things like chicken and pigs in the UK, feed is still there and much of the feed is imported. And there's still quite a dependence on soy, which is imported and is associated with deforestation. And so that's something that technically could be avoided. And then we were going through you saw the tips that Rachel gave earlier. I would say one which I would like to suggest, if you know that your meat is deforestation free or your food is deforestation free, then there is a big chunk of your emissions signature that's gone. Okay. You can see a similar effect with pigs, manure management, that sort of thing. This is all farming. I'm going to whiz through. There are things that can be done. You can cycle manure and waste more efficiently. A couple of examples on the right here, just to show that this isn't theoretical. There's a paper published in 2018 looking at large-scale egg producers in North America, where farmers got together, used carbon calculators, and over 1 year, reduced their emissions by 25%, just by comparing results and interventions and learning from each other. If you want to see how some of this plays out on real farms, then there's AJ Duncan Farms, which is not far from Aberdeen, just up in Turriff. There's an article there which you can go and look at and see how they're approaching the problem of producing a net zero egg. Okay, I'll whiz through. Ruminants, more of a challenge again, as you know, so pretty much the same graph here. What you see, these big orange parts of the bars there are so-called enteric fermentation. These are the methane emissions from burping ruminants, and that's still a big part. But there are technological interventions that are being tested to reduce that, so-called methane inhibitors, and with some quite incredible results, which I still raise my eyebrows when I check the paper and say, wow, it does really seem to be the case. But I take one example here where feeding red seaweed to cattle in rather small doses, a particular type of red seaweed, actually suppresses methane emissions by about 80%, which is quite incredible. The challenge is actually, how toxicity needs to be looked after. The persistence of that effect needs to be ensured. You need to find ways to get that seaweed into, say, grazing systems where it's not, which is different from a feedlot where you can really control the feed. But I think there is significant potential in that kind of thing if you find that palatable to give inhibitors or mix something into the feed of livestock that will reduce their emissions. Okay.
John,
Yeah.
it'd be nice to have about half an hour of Q&A. So
I'll do 2 more minutes, Adam, if I could.
perfect.
I want to just mention carbon sequestration in agriculture. It gets a bad name. If you can't cut those emissions down to zero through reductions that I've highlighted, agriculture has the unique potential to sequester carbon in large amounts, okay? And there are good examples where silver pasture systems have been applied in practice and on arable systems. So there are tons and tons of carbon that can be saved per hectare. And I believe you can go through past net zero and below if you implement these. I'm coming to my conclusion, so appreciate the nudge. Adam, I think very quickly on here, the technical potential to mitigate greenhouse gas emissions from food production is large. It's probably as large as it is through diet, although some of these technologies are not quite ready yet, and not always easy to see and realize. I did want to just spend a little bit of time on this slide because it's been mentioned a couple of times by David and Adam as we go through. I think the challenge that I have, you know, even having worked in this area for a long time, is that when I go to the supermarket, I still don't know which foods to choose. Apart from knowing, you know, that red meats are up at that high emissions end, I can't look at a product and say, yeah, this one is better than that one. I don't know how it's being produced, so I can't see what practices the farmers have implemented. Okay, there are calculators, and farmers don't know this themselves either, actually, you know, and there are calculators that will help them. I've just listed a couple here. But this thing about the role of retailers and consumers, you know, I think is interesting. This initiative by Tesco's, yeah, was dropped just over 10 years ago. And they had intended to footprint over 70,000 products across their stores. And I heard both reasons for them having given up on that pledge. One was, as David said, it's the kind of practicalities of doing this across 70,000 products. And the other is, as Adam said, that when they'd spoken to consumers, they'd found that consumers just really didn't care. You know, they weren't going to change any decision on purchasing based on what they'd seen. In fact, they didn't really know what the numbers meant either. I sense that that is changing. There is a recent survey by Tesco's and WWF that says now 80% of customers say supervisors should offer more responsibly sourced food and say they would be willing to pay for it. Okay, so I do see that changing. My last conclusions, yeah, I still think we're going in the wrong direction with global greenhouse gases. I think until we know more about where our foods come from and how they're produced on a product level, going vegan is probably a good idea if you want to reduce your carbon footprint. Okay, but there's lots that can be done on the other side. I think there is a role for consumers. We signal what we will pay for, and retailers will respond. And that is me just over time, and I'll stop there. Thank you.